This is World Oil Deep Dive's special series on oilfield electrification technologies, powering today's oil field for tomorrow's energy. Join us as we talk with industry experts about technology ranging from microgrids to e-frac to offshore electrification and more. Now, here's today's episode.
All right, everybody. We're here in Duncan, Oklahoma, the birthplace of Halliburton, for a very special episode today because they're rolling out some incredible new equipment, and we're here to bring it to you live. And so right now I have with me Sean Stasiak. Sean, welcome to the show.
Thank you very much.
Yeah, Sean.
Glad to be here.
Yeah, no, this is exciting for us. You know, I mean, we're media, man. So usually we're locked up in some small room somewhere, some dimly lit room. But to be able to be out here in this shop in Duncan, Oklahoma, I mean, it really is. It's exciting. It's exciting. I don't know if you get excited because you're here all the time, but
no. We love being here. Yeah, I mean, you're on the line floor. You're where all the magic happens here. So yeah, no, it's good to have you guys here. We're excited to have World Oil, and we're going to showcase a lot of technology today. So
that's awesome.
Glad to have you here.
That's awesome. Well, Sean, you know, I always like to start by having my guest talk to the audience a little bit about your history, your path, and how you got to the position you're in. So can you give us a little bio background and tell us what you do here now at Halliburton?
Yeah, so my name's Sean Stasiak. I'm the Vice President of Production Enhancement. That's our pressure pumping business here at Halliburton. I grew up in a small town in northern Canada.
Oh, wow.
So it was a farming community, and really at that time, they started to figure out that there was a bit of gas underneath all those crops, and that was the ℚ Formation.
Okay.
And so there was a lot of drilling and that kind of activity. So I kind of spurred my interest in the industry in oil and gas. Graduated out of the University of Calgary in Canada, and started at that time, I think oil was at like $13, and there was like, everyone had told us there's so many opportunities in oil and gas, and I was like, okay, well, where are they? And I think I was looking at a job at a golf course at that time.
Wow.
Struggling. And then you know, just through the oil and gas community, it's all who you know and that kind of thing. And so ended up working at a wireline company. That's how I got my start as an open hole wireline engineer.
Wow.
And then ended up moving up through the ranks. And in 2009, Halliburton bought Pinnacle. So Pinnacle Technologies. Right. And so, or 2008, and I came across shortly thereafter, started with Halliburton, been here 15 years now. And so moved to Denver, and then eventually ended up in Houston. And from Pinnacle, I made the transition over into the kind of the core pressure pumping business, really with the Zeus, the electric equipment.
Oh, wow. Yeah, right. Yeah,
exactly. So in 2018, I got a chance to kind of work on the commercialization of the Zeus technologies. And so did that, and then worked on some strategy and things like that, and then had a chance to kind of transition into the VP role.
Nice. So you've been around for all of Zeus then, basically?
Yeah. Since it's certainly since Zeus 2, since its inception, and then it had been around for kind of our first generation as well.
Wow, that's impressive. Well, hey, let's start, before we start getting to equipment and stuff, they say you're an expert on the history of frac. Yeah. So why don't you give us a little history of frac? Because I'm quite curious. You know, this is my first trip to Duncan, and you know, why Duncan, why things are the way they are, why, you know, that whole part of the history is fascinating to me too. So hopefully you can touch on that a little bit.
Yeah. So I mean, so you're here in the birthplace of Halliburton, right? That's also the birthplace of hydraulic fracturing. So
really,
yeah. So hydraulic fracturing turned 75 years old this year.
Okay,
a little unknown fact.
Yeah. Why didn't we celebrate
more?
That? Exactly.
As an industry, we need to be proud of that. So 1949, March 17th, 1949, Halliburton performed the first commercial job just outside of Duncan.
Really?
So about 8 miles from here.
And that was just all vertical wells, and same idea though.
Yeah. Same premise. I think I'm not exactly sure how we ended up getting the patent structure or our license to the technology, but we did the very first commercial job on March 17th, 1949.
Wow.
And so at that time, a typical or a job was that they were pumping them about 3.5 barrels, 3 barrels a minute. And we didn't have our own pumps. There was no such thing as a frac pump at that time. So we had to use a cement pump, and it was a steam-driven cement pump. And so you can see kind of some of the pictures from that. They see the steam and all that. That's what that's there for, is to drive the pump.
That's hilarious.
And actually, we have some of them on display here in Duncan.
Oh, really?
Yeah. I mean, there's a rich history. You can kind of see the evolution of the pumps over 75 years. Yeah, it's crazy to see. But those first ones were steam driven. The other interesting thing is that like the fluid system at that time, we were using gelled kerosene. Yeah, so it was gelled kerosene or oil was kind of the base fluid at that time. Yeah. And what we saw on the back of that was, man, I mean, fracturing worked. It was a huge success. We saw this massive production uplift in the state of Oklahoma. And we did a similar trial in the state of Texas, same effect, right? So we saw this big increase in production, and that was it. Fracturing was born. It took off from there. And so if you fast forward to 1963, so I've got a picture here of from 1963, and what you can see is what the industry quickly figured out was the need for like higher volumes in the ground equated to higher production.
Right.
So the more we put in, the more we got out. The higher injection rates, the more we got out. And so that really kind of dawned the need for specialized fracturing equipment.
Yeah. Because the pumps, when you were saying they were using basically pumps that were used for cementing, because that's the birth story of Halliburton, right?
Yeah,
that was the first thing they were doing was cement jobs, right? And then they're like, hey, we have a pump, let's do that. And then all of a sudden, wait a second, we need bigger pumps, right?
Yeah, and we always need bigger pumps. So we love bigger pumps. I mean, that's really that's in everyone's DNA here.
Right.
But yeah, so we went through this evolution from 75 horsepower cementing units, steam driven. Now we've got diesel powered. I think at that time they were about 1,000 horsepower. And it's interesting to see kind of those 14 years from 1949 to 1963. And I referenced 1963 because that's when this picture is from.
Oh, okay.
But it's interesting to take note. If you look at the image, I mean, everyone is in what we call the red zone or line of fire.
Right.
I mean, there was no kind of red zone at that time. And you'll see some individuals on the back of the pumps. And so their job was to really control the system. So at that time, everyone stood on the back of a pump, and that's how they were really operating that. And apparently, I've been told that the really good ones, they called them pump whisperers.
Oh, right.
Yeah.
They could just right.
Yeah, or they could hear if there was something going wrong with
wow.
one of the pumps. And so their job was, okay, I can hear that this particular unit is not functioning right, and then they would take it offline and do whatever they would do. But what happened was we transitioned from like 3 barrels a minute. Now we're pumping 22 barrels a minute. So that was a big shift.
Oh, yeah.
Now we're at like 1,000 horsepower units. And we moved from like oil-based or gel kerosene. 60% of the fluid is now, it's aqueous-based. So we saw that transition happen. But again, I mean, no HSE regs. There's nothing. I mean, everyone is in the red zone here.
Yeah, that picture is hilarious, right?
So you transition now, 1983. So we're now in 1983. And to come up with this slide deck, I had to think about a lot of trivia for 1983. So what was going on in the industry and what was going on in the world in 1983? So I think you have like Lionel Richie's on the top of the charts. You have Return of the Jedi is in the theaters now.
Nice.
I mean, it's the number one movie. Yeah, exactly. And this is the first reference I can find to really digital tools being used in the industry. And so in 1983, Halliburton launched a technology called ARC.
Mm-hmm.
And it stood for automated remote control or automatic remote control.
Right.
And I think it was a little bit aspirational. Although equipment was still important, we started to see the desire for new digital technologies.
Right.
And so in 1983 is really kind of the first time we see that.
Interesting.
And it's a bit of foreshadowing, I think, for where we are today and some of the stuff you're going to see as part of this tour.
Yeah, but that's a long road to climb, right? I mean, from 83 to what we're at today. I mean, it's Star Wars, we're light years away, right?
Yeah,
I mean,
exactly.
It's light years away, but still, I mean, so in that early in the ARC era, what were they doing? What were they controlling?
I mean, it was still really, really basic capabilities, but I think the intent was that they would the ability to remotely control a spread was there. The thought process behind that
people were
existed.
Like, hey, we could do this remotely
Exactly.
somehow.
At some point in time, we're going to be able to do that. And I think that was kind of the precipitation. Actually, you're going to see a fully autonomous spread here today.
Yeah, I'm excited about that. That's going to be crazy.
So if you fast forward now, kind of modern day, here we are, 2024, really, I bring up that past because the speed of change from 1949 and the innovation to go from 1949 to 1963 was remarkable.
Right.
A ton of change, a ton of innovation in the industry. The last 4 years feel very similar. So the speed
More
of change,
compact.
I mean, 2020 to 2024 is a complete shift.
Wow.
In the technology landscape in terms of how we perform jobs on location. I mean, it's completely flipped the narrative. And these pumps that we're standing beside are part of that story. So you now have, I mean, we're here in Duncan. You'll see as part of the tour, but we've got robots building fluid ends here.
Really?
Yeah. So that's super cool. Yeah.
Very cool. Yeah.
You've got now, we've got electric horsepower. So now almost half the portfolio, half the portfolio will be electric for Halliburton next year.
Next year,
Yeah.
not 5 years from now.
No, next year.
Wow.
And we've got 5,000 horsepower pumps. And then we just pumped our first autonomous frac job. So fully autonomous frac job.
Wow. That is amazing. That is amazing. That is the future. And that's the great thing I love about our industry is that we're always striving to make technological advances basically for a profit motive, right? I mean, why not? But that, when you see something and you're like, wow, that's crazy. And it's here. It's not like, something a decade from now. Oh yeah, we're working on that. We'll get to that. We're seeing it in front of our eyes today.
Yeah. I think that, we have moved from the PowerPoint era to like, this is actually real and in the field and happening. And that's what's so exciting about it is we're done talking about it. We're putting it to work.
Right. Nice. So tell us a little bit about what we're standing in front of here. I mean, we can just give us a little idea.
Yeah. So this is what we call, actually, it's a Zeus 2.2. So this
2.2?
is 2.2. Yeah. So it's kind of our third generation in the Zeus series. And there's some new capabilities, new feature sets with this system. So we started out with Zeus 1, really simple, single pump, 2,500 horsepower type unit. And we've got a couple of those running today in Colorado. What you see before you, though, is the Zeus 2.0 platform. So we've got two 2,500 horsepower pumps here, 5,000. Actually, it's much higher than that, electric motor, and then a VFD on the front. So this is the workhorse for Halliburton now.
Right.
And so this thing is capable of delivering 5,000 horsepower.
Right.
So we're super excited about it. And some of the reason we call it 2.2, we've added some additional capabilities. So all these pumps, and we'll do a deeper dive on it, but these are all modular now. So we can lift this stuff on and off. So this is all, if you think about it, it's all Lego blocks now.
Really?
Yeah. So all this stuff can be forked off, put on the ground. If we had to change something out, we just fork a new one on.
Nice.
Yeah.
Yeah, that's fantastic for, minimal downtime, whatever. And can you, I don't know, I'm not a technical guy, but is it possible to isolate, to go to one pump if you're working on one? Can you keep going with a single?
Yeah. So we've got an ability to disconnect between it. So if we were, for instance, if we're pumping a job and we see an issue with the fluid end here on the right, we can disconnect that fluid end on the fly.
Wow.
And keep pumping with this one. The cool thing about electric is because of the controls and the performance on it, the formation doesn't see a change.
Right. So the pressure just stays constant.
It just stays. And actually, the automation just ensures that we rebalance the whole portfolio. So all the pumps rebalance themselves automatically.
Wow.
And the formation doesn't see any change. And that's important because we ran enough now technology in the ground with all the fiber data that we run. We can tell if we back off in terms of rate to formation or to the cluster, we can close down those clusters and we'll never get back into them.
Right.
And
so you got to keep it constant.
Exactly.
You got to keep it going.
Exactly.
But again, that wouldn't have been possible without automation, without computers controlling it. There's no pump whisperer could have pulled that off, right?
No. I mean, we it's crazy. We actually went in and we tracked like how many mouse clicks per stage there were, and it was in the thousands.
Thousands,
yeah,
really?
So you're making thousands of decisions during a typical stage.
That's crazy.
Yeah.
That's crazy.
It's a lot.
Yeah. Well, I'm looking forward to that autonomous unit so we can see how easy it is today. No 1,000 mouse clicks anymore, right?
Exactly. Yeah.
So, all right, Sean. Hey, before I let you go, let's get into a little bit about the strategy and what you guys are working on now.
Sure. So in the pressure pumping business, which is kind of my remit, what we're looking at is really kind of three things. I mean, and it's always kind of top of mind for us, and it's true for the industry at large as well. So the technologies that we deliver to the market, the solution sets we deliver, they got to do three things. One, they've got to lower total cost of ownership.
Right.
And really that's kind of what Zeus is on the back of that, right? So how do we use gas to lower total cost of ownership? How do you burn the gas? Because you got to do something. In some places where you're working, you've got to do something with this gas. Can't flare it off, so it's better to use it. So how do you lower your total cost of ownership? So that's the Zeus platform. The second thing is how do we drive efficiency and consistency? So I think we're at the dawn of where everyone's going to be pumping 24 hours a day.
Right,
That's an inevitability. We're probably a couple of years out from where it's really kind of happening at scale, but I think you're going to see that happen. And so it's now going to be about, what do you do with those 24 hours? How consistent are you within that 24-hour period? And that's really where the automation comes into effect. And so we spend tens of millions of dollars in R&D here in my division. And a big part of that is going towards kind of the automation piece. And so what you'll see today is basically some of the new technologies that deliver on that.
Nice.
And so we can get it now where we can consistently deliver a stage where they literally will stack on top of each other.
Really?
Yeah. If you think about, there's a ton of variability in terms of how that gets delivered. Well, all that variability is technically waste.
Mm-hmm.
And so now you pulled that out, you can consistently deliver that. Because it's automated, actually, we can go much faster as well. So that's some of the early stuff that we're also seeing. So that efficiency push as well. And then the last one, we have a new technology, sensory, which we're going to do a deeper dive on. But really, that's how do we get subsurface information at scale? So to do that, we had to kind of solve for three things. We were challenged as a business unit to look at, okay, how do we make sure that whatever we put in the ground is non-invasive? So what I mean by that is, how do we ensure that it doesn't impact either the drilling efficiency or completions efficiency?
Right, yeah.
So we needed to check the box on that, which we did. The second thing is how do you make it so it's cost effective? So it's not basically so cost prohibitive that no one actually runs the technology. So we've been able to check the box on that. The last one was, how do we ensure that it's fully automated? So one, we don't have to have a lot of people babysitting the system out in the field. And how do we ensure that the data is automatically processed and flown or embedded into the customer's workflows?
Right.
And so that was the final check the box on. And so what we can do now with this technology is now we can capture subsurface information at scale. Then you can start to feed that into kind of cause and effect models.
Nice, yeah.
Yeah, so you can start to say, well, we saw this happen, and therefore this is the action we're going to take.
Right.
By the end of this year, we'll be able to start then automating those.
Yeah, because that's the thing, right? The quicker you can take action on that, if you know when this happens, we need to do that. If a human's involved in the loop, that's going to be slower than a machine going, okay, this, that.
Exactly. Yeah, and I think that decision-making is getting so complex in the field that, yeah, we simply can't keep up with it anymore. And so you've got these massive models that are being built behind this, and now a lot of those workflows are being kind of automated. So that we've now got, as of this year, actually last year, all of the Halliburton spreads in North America are fully automated at its base level. We completed that journey.
Wow.
Yeah.
That's amazing.
Yeah.
That's amazing. I don't think there's any other, pressure pumping competitor out there who could say that, right?
No. I mean, I haven't heard one, and it's been a journey. I mean, we started with the diesel pumps and worked our way through the system. And yeah, so every spread within the portfolio is fully automated. Wow. And now we're going to be layering in a bunch of new capability on top, which you're going to see today.
Excellent. Well, thanks a lot.
Thank you very much. Appreciate it.
All right, everybody. Still here in Duncan, Oklahoma, on the outside. The weather's been cooperating nicely with us. It was raining cats and dogs this morning, but it is beautiful now. And now we're out here amongst the actual equipment. So we have Chris Atchley with us. Chris, welcome to the show.
Hey, thank you. I appreciate it.
Yeah,
Good to be here.
My pleasure. Hey, Chris, before we get rolling here, though, tell the folks a little bit about what you do at Halliburton, kind of like how you got to this position, a little bio.
Yeah, no, prior to coming in and working with all our Zeus equipment, I ran a business development team in Houston, mainly focused on stimulation. In the last 2 years, all I've done is our Zeus project. So,
oh, wow.
I'm a Zeus editor, and this is, and I work with the operations team that deploy it, our sales teams that sell it, our manufacturing team that builds it, and our engineers that actually design the equipment. So, it's been quite the journey, at least over the last 2 years.
So these are kind of like your babies. You feel like you're like sitting like mother hen on the nest. So
that's exactly right. All right. So it's been, when I came into the program 2 years ago, and we just had a couple of electric fleets run in, and it was really an evaluation of how we scale the business, right? Because I knew we had something here that was going to change the industry, or at least change our portfolio. And it was how do we ramp this and build a sustainable program that can get to scale safely.
Right. Yeah. Exactly. And here we see the fruits of yours and thousands of other people, all laborers for sure, right? Yeah. So walk us through this. Walk us through, first of all, the general equipment. So the whole skid, everything that's set up on there, and then we can talk about the connectors and stuff later on.
Okay, yeah, absolutely. So you'll notice one big thing that's changed from diesel to electric, right? There's no engine setting here, and there's no transmission. Right. You've got a variable frequency drive at the front that's taking power into our electric motor that's driving both power ends. It's driving the fluid ends that push the fluid down hole. Big advantage there is now we don't fail engines and we don't fail transmissions. Now, you may not fail an engine on every location, but what you do is you take a lot of different people to manage that. So they're changing engine oil, they're looking at things, monitoring, all of that kind of stuff that goes on. With this, we don't need the people doing it. So we can focus on other things, right? Yeah, stage transition times, pad transition. So what you end up with is a more effective product on location that's more efficient. So that's what we see with operators today and why they're transitioning. So,
Sean was telling us that 50%, by the end of this year, 50% of your guys' fleets will be electric.
We'll be close. End of next year will be 50%. Why? Sean's a bit aspirational, but no, it will be a large portion of the Halliburton portfolio, especially by the end of next year will be 50%. It's a large piece right now if you look at it, right? We're close.
Oh, absolutely. I don't think anybody who's out there, except for the guys who are just exclusively e-frac, right? But yeah, I mean, I don't think there's anybody who's got mixed fleets out there who has anywhere near that percentage. Right?
No,
I mean,
no, absolutely. Yeah. You have groups that have kind of one or two, or they're kind of entering the market.
Right.
One thing when we present to operators, we talk about we have an electric business at scale, which is incredibly important when you think about one thing, your supply chain. How do you build out the right parts and inventory and the critical spares you need? How do you train your teams, right? We've got competency programs now where we actually develop our own medium voltage electric experts that are on location.
Yeah, because that was always a problem, right? Because, I mean, when you start using the type of electrical power it needs to run this, we don't have guys who do that, though. They might exist.
So you train them up. Yeah, that's absolutely it.
Wow. So we got the VFD, we got everything in there, cranking, coming through. Explain to us the rest of the setup here.
Yeah, so right here you have the fluid pump, right? So today, this pump itself is 5,000 total horsepower. Now, that's not nameplate horsepower. That is actually what we can get out of the back end of the unit. So we'll run this at 5,000 horsepower on a routine basis. Now, like Sean talked a little bit about inside, continue to innovate, right? How do we make the product better? And one thing we're fixing to do is move to a power end that will allow us to use 6,000 horsepower. So plenty of motor. So we'll take this up and it'll be a full, out the back end, not nameplate, 6,000 horsepower on a well site.
Yeah, that's interesting because the motor isn't the limiting factor anymore, right? Like you were saying, it's actually the power end, which is over on this side.
Your power, absolutely.
Yeah, exactly. No, that's fascinating. And so one of the other things I think that Sean mentioned is that these new platforms, all of this is modular, right? Like this is the whole control box and the VFD and everything. That's all assembled, and then you just plop it down, basically.
Yeah, in the assembly process, we'll have that come out of Houston. We'll take it, we'll put it on the chassis, wire it all up here in Duncan, and it's manufactured and put out to the business here. Now, one of the cool things that we've developed over this last year is the modularity of actually the pumping units themselves. So a couple of challenges in North America land is how do you get the units into weight-restricted areas? So like the DJ Basin, they're in frost laws. You have to be really careful what you're going to drive. It's just, you can't take that other electric equipment there because it's too heavy. So we have to figure out a way to lighten the unit up. So these two actually, and we'll show you in just a minute over here, these two pumping modules will actually come off. So we'll bring a forklift in, they can pick them up, set them down. And the advantage is
separately. Oh, they're all sleep, right? Yeah. They're nice.
But also when you think about it, how do you drive that efficiency on location? We don't necessarily need the weight restriction, but from a spare equipment standpoint. So now, if your VFDs don't fail, electric motors don't fail. We've been running these similar motors since 2016, 2018.
Wow.
And we haven't had a failure yet. So you don't have those don't fail. The only thing you really ever need to change are power ends, fluid ends, and maybe something with the loop system. And we've got that all in these modules now. So now instead of having to build extra chassis or have the spare full pumps on location, we can just build these modules. And when you have a problem on location, you just pull one off and put another one on, and you're back to go.
Wow. That's impressive. Yeah. And, now, I mean, the advances off of even just, you guys started the Zeus thing, but even the original Zeus, it wasn't modular like this. Is now Zeus 2?
Yeah, this is actually 2, the 2.2. So we have so over to 2.1 to 2.2 is now our modular system. So we continue to iterate. I mean, airflow designs, everything's about how do we improve consistency and reliability at the well. Yeah, and that is key to driving cost out of the system, right? And we all know in North America today, it's all what's the lowest total cost of ownership. So our goal every day is how do we develop a better product that's going to deliver that value proposition to the client.
Yeah, and now, and so you have these units. I mean, here we have some set up. These actually look like they're all hooked up. Are they can you run them? Is that what I was running when I was over in the...
Yeah, so this is actually, when you were in the shed right now, but these are the actual pumps you were running.
No, really?
Absolutely.
That's exciting.
So it's really cool, though. When you look at it, you think electric, you think, man, I have cables everywhere.
Yeah, where are the cables?
Yeah, where's the house? I didn't see any cables, right? It's because they're all in the manifold. So the way our system's built is we design everything so all of the cabling stays on the manifold. It lives there. A couple of key advantages to that. One is cable life. Make sure they're safe. They're out of the weather. They're covered well. The guys aren't having to pull them around trying to rig up. We're not having to lay out a bunch of cable that takes up a bunch of time when you're moving from pad to pad. It's one thing. No one's going to move to electric equipment if it's slower. Right. Yeah, and so we have to effectively be able to move from pad to pad. So now we don't have guys moving cables around. They'll show up on location. They'll take out the cable, plug it right into the back of the pump, and they're done. So it's super quick process.
That is awesome. And because they're not floating around and they're not free floating, everybody knows, right?
Yeah.
If you're rigging up one of these systems, oh yeah, the cables are right there. Let me just grab them and stick them in.
It's about building a very consistent product, right?
Yeah. No, this is impressive work. So this is 2.2 now. You said we're right. That's where we're at. Zeus 2.2. So, I mean, it seems like, you've worked all the kinks out of the system. Okay, we can get the power in. We can ramp that up a little bit because, all the rest of the system can take that. We can get 6,000 horsepower out of it. But where else can you go, like on the design or automation side, to get even more out of it? It seems like we're like reaching the peak.
Yeah, so that's what you saw in the van with Eli. Right, yeah. You think about the next iteration. Like people ask us, okay, what's Zeus 2.3 or 2.4? But again, it goes back down to what is the most consistent thing you can do at the wellhead that provides the best total cost of ownership. And that's some of the automation you saw in the van where we're using auto frac, right?
Right.
And what you're doing is you're driving that consistent fracture. Right? It's amazing when you look at different frac plots over even like one of our engineers running it, where there's day shift or night shift or a consultant, and how they bring up rate.
Yeah.
But it's never consistent. It's always just a little different variation. And what happens is you get time leakage. You maybe took a little longer to come up to ramp. You pump a little more chemical, right?
Right.
Which on a per stage basis isn't a lot. When you add it up over a month or even a year time horizon, there's a lot of money there. Right?
Yeah.
And so you apply the automation, you pull everything in where it's really consistent, and then you save all the money, you save the time. There's a ton of advantages to that. Not to say you're also treating your wells in a very consistent manner.
Yeah, and Eli was telling us that it's just better for the equipment too, right? Because you can run it at the sweet spot. I mean, the automation knows where everything at. He said that it's like 25% longer life on all the equipment when you use.
The more consistent you are, and you use the computer to run everything, it improves the component life all the way through.
Wow.
Absolutely.
So we talked a little bit about taking these 225s up, to 6,000 by changing.
Yeah, move the whole unit to 6,000.
Yeah, exactly. So when is that going to happen?
We've got one in the field working today.
Oh, it's being tested out right now.
Yeah, it's in the field running today. This isn't it's not a pretty photo and on LinkedIn or something. This is something we're actually doing today, and it should hit the pipeline where it's actually just part of the manufacturing process sometime this summer.
Wow! And so, what are the advantages of going bigger? Is it just more power to force?
It's just a high density horsepower. So the higher density you can get, the smaller your footprint is, right? Because if you're pumping a simul-frac at 160 barrels a minute at 8,000 PSI, it's the difference of maybe do you want 12 pumps out? Do you want 14? So it's about reducing the footprint on location, but also improving the life at higher pressure. So we work, all over the United States. If you're in the Haynesville at 12,000 PSI, a bigger, thicker case that's capable of 6,000 horsepower is going to last longer than what we've got today. So it's about driving better reliability out of it.
Yeah, definitely. And you mentioned a little bit earlier when we were talking about how you got simul fracs, which I think everybody knows about, but then you got like triple fracs and quadruple fracs.
Oh, the industry, that's one thing I love about oil and gas. It just continues to change. And we get to one horizon where we think, man, that's great. If we could do this, it'd be fantastic. And then somebody challenges, well, we could probably do this a little differently, and let's get 3 wells. What happens if we try 4 wells? And so we'll see where it goes and where it ends at. But yeah, no, I've got electric crews right now doing anything from just your standard zipper operations to simul frac to trimul frac.
Trimul frac.
We're doing 4 wells here coming up. So there's a lot of movement. But what this allows you to do, the high density horsepower, is you can go do a trimul frac with much less equipment. Like if I look at, let's just talk simul frac for a second. If I look from blender to wellhead, with a diesel crew, I'm going to have anywhere between 30 and 35 pumps, depending on what that rate variation is, between the blender and the wellhead. And then I'm going to have a standby location where I'm going to have 5 or 6 pumps sitting on that standby location, ready to rotate out as things break, right? Mm-hmm. With electric today, we're doing that with 12 pumps in line, right?
That's 12. That's a
ETG. So you move all of that equipment, and you don't need the standby pad full of like spare pumps and all of that, because the kit it's that much more effective and reliable.
That's amazing. And it's amazing that we get to be out here looking at this, firsthand, right up against it. So thanks so much for taking some time with us and giving us the tour here today. And I'm sure we'll see you again, because you also, look, you got it on your sleeve right there. You're also in charge of the work you guys do with VoltaGrid, right?
I do. I work a lot with our power generation. When you think about electric frac, there's really kind of 3 tenets to it. One is you have to have something that's effective that's going to pump, which we've got. But you also have to have a way to power. You have to have a way to fuel the power. So there's a lot that goes into that side of the business.
Yeah. Well, we'll catch up with you over at VoltaGrid's area.
Okay, sounds good.
Take care.
Thanks.
All right. So now here we are over to take a look at how modular these pumps are on these rigs. So why don't you give us a little explanation of what we're looking at here?
Yeah. So really, what we're challenged with in the electric market is with the high density horsepower, and these units, they weigh a lot. So how do you take it into markets that have road restrictions, right? Weight restrictions, one like DJ Basin or the Bakken up in Williston, right? And so the legacy high-density horsepower solutions just, frankly, don't work. You can't take them there.
Right.
So what our engineering team came up with is, well, what if we could remove the pumps and the power ends? And then it was like, well, how do we put the full loop system on that, right? So what we developed was a modular frac pump, high-density frac pump. So as you can see behind me with the unit, we've got right here, this is a Zeus 2.2 frac pump, but there's no pumps. No power. That's not loop system. It's just the motor and the variable frequency drives, right? So you can take them off. This unit is completely road legal. Williston, North Dakota, DJ Basin. So now we can take high density horsepower to any market in U.S. land.
Wow. That's a big game changer.
Yeah, no, honestly, it gives us access to a whole different market that we didn't have with our high density horsepower before. And if you'll look over here, I'll actually show you. This is actually the back end of this pump. So when we looked at everything put together over here, this is the module, this is the skid.
Right.
So what we'll do when we're shipping to location is we'll just take them off, we'll put this on a separate trailer, and we haul them separately to location. This way we meet the weight restrictions.
That is amazing, and that's ingenious. Whose idea was that when you're thinking about that, right? I mean, because it seems very simplistic. It's like, so why wouldn't we just make it so we can take it off? But, that's not something that's been done before. So how did that come up? Was there a meeting like, hey, man, we got to get the weight down on these. What can we do?
Well, I'll tell you, one of the fun things about working at Halliburton is we've got a massive technology team that is extremely experienced. And so, man, when they look at something, they'll come up with some creative ideas, and some of them are really out there. Some of them are like, you look at it, they're like, I don't know. But what they can do is take kind of some of that, what we'll call fantasy, and make it reality, right? Like, wow. Sean talked about part of our advantage, right?
Yeah, right.
It's, man, we build, we manufacture, we design all of our own equipment. So when it comes to this, we don't have to go to a third party. We're not doing this. It's like we'll have some guys sketch it up, and then we can build a mock model of that in a few months and say, okay, yeah, hey, that works. Let's go make that change, and that's what we're going to drive in the portfolio from now on.
Wow.
Right? So it's quite the concept. But also, talk about weight restrictions. That's one advantage to this. But the next is when you think about how you conduct like a spare equipment program or how you do maintenance on location, think about the changes we can make with this.
Of course, yeah. You just take the whole thing out, drop a new one on, go do your servicing, and bring it back.
That's exactly. You don't have problems with the variable frequency drives. You don't have problems with electric motors. It's typically a power end or fluid end issue. So now you build these as your backup equipment, and you just swap modules out as you need to. So it's a little bit simpler, a little bit more efficient for us.
Yeah. So the fluid ends get swapped out more frequently, right?
Yeah. Fluid ends get swapped out more frequently.
But so is it quicker to do a traditional fluid end swap, or is it quicker to just say, hey, let's just pop that whole thing off, put another one on, and we'll work on that over there?
And there's a ton of different scenarios. It's all about what drives the best time on location.
Yeah.
So if it's something to where maybe you're in a pad transition and you want to just pull it off and put another one on while you're making that transition, you can do that. If you're on location and you can make a quick fluid end swap right there at the pad, we'll do that. So they'll make the evaluation. We've got really good service leaders on location that'll drive that process for us.
Well, I'm telling you, man, this I think it's always like that, right? When you think about any design, anything, simpler is better. And I think this is just a prime example of that, a super simple solution to a serious problem that's a game changer for you guys.
So, absolutely. It's about providing flexibility to the teams that need to execute. That flexibility allows them to do everything at a really high level.
Well, thanks for giving us a tour. I appreciate it.
Appreciate it.
All right, now we're here at the power generation station. We've been talking about the e-frac and all the electricity we need for that. And so now we're out here with your, I don't know, don't want to say partners, say something else. I don't know. With your,
power provider.
Power provider. There you go. VoltaGrid, which runs this side. So why don't you walk us through this?
Yeah, absolutely. So like we've talked about, there's a couple of key components here, right? One, when you're going to go electric frac, you got to have a really good pumping solution, which we just showed you. We walked through that, talked through it. Next piece is you got to have power to power the units. You got to have good, reliable fuel source. Make sure you can power equipment, right?
Right.
So you got to have that three-legged stool, or none of this comes together. And you're right, VoltaGrid has been with us really since day one. So, one thing we talk about at Halliburton is we're power agnostic. We'll work with whatever power supply you have. But like we talked about, VoltaGrid's been with us since the start. And one of our real advantages here is we found a power provider that we can work with to help develop our systems, right? And that gave us really an advantage to the market to where a group we could scale with and scale together and be able to drive really the efficiencies between the two organizations that are needed to be effective on location.
Yeah, because if you planted on having, half of your frac fleets electric, you want to make sure that you got a power provider somewhere.
Those things don't do a whole lot of good.
Exactly.
They're nice to look at. I'll give it that. I'd say it's great.
So walk us through this. This is the actual power generation unit.
This is fuel. So this is fuel. This is a CNG trailer. And what this is doing is going into this pressure reduction skid, and then we're fueling the just cat generators that are on the other side. Now, a couple of comments on fuel. When you're thinking about how you most effectively drive cost out of your system is, do you want to use compressed natural gas, which is, I would say, predominantly a large part of the Permian Basin today, or do you want to use field gas applications like we see in the Northeast, or we see, in Haynesville, Eagleford, and even some Permian applications, right? But it's about how do you drive the most cost-efficient fuel program? And so VoltaGrid does, they have a massive CNG business, but they also do field gas compression. They'll clean up your field gas. Maybe it doesn't have the right methane number that the recip engines may need. We can clean that up and take your number from like a 30 methane number up to a 70, so we can effectively use your field gas as well.
Wow, that's impressive. Yeah, and I saw on the side of the truck, I don't know if we have that in the shot, but I got to give a little shout out. There's a little hydrogen symbol on the side. and we also have a brand called H2 Tech. It's all about hydrogen technology, so I guess they can use hydrogen if that's what they have too, right?
Oh, there is an opportunity there was that the gas can take a percentage of nitrogen, and some of their newer technology like the Yrmbachers can use a certain percentage of hydrogen. So, like we've talked about as we've gone through all of this, all of us continue to push the limits and really innovate on the technologies we've already brought to market, right? So how do we continue to get better? One future look is that if we have the opportunity where hydrogen is a scalable business, how do we apply it? So we're already kind of thinking about how that process would work.
Interesting.
Yeah.
So you have the fuel source here.
Yeah.
We'll go to this unit.
Yeah, this unit. And then it'll actually run over it. I'll show you. I'll point over here where you can see it, but we'll have the Cat 3520 generators over there. Then you generate the power. It goes to a switchgear. It will come out of that switchgear into Halliburton's power distribution unit, and then we distribute all the power to the fleet.
So, like you were saying, you're power agnostic. You could take any power. You just have that power distribution unit, plug into that with whoever's providing whatever power, and you're good to go.
Absolutely.
Wow.
And when I say we'll use anything, like I'll give you some examples. Like we have where we work with VoltaGrid and line power. So I have an iteration where we'll have maybe 5 to 10 megawatts coming off overhead line power the operator may run. Mm-hmm. Then we'll parallel that with some Cat 3520 recips, and we'll use line power, but we'll also use mobile power generation. We'll synchronize it on VoltaGrid switchgear and then send it to our power distribution unit. So it's really, if the operator has some sort of power available, if they've already paid for it, it's not cost. You might as well use it if you have it. So we'll parallel those and do that. There's a couple of opportunities where we actually run line power every day. That's all we do.
Oh, wow. Yeah.
So really, it's about providing, again, back to the flexibility, like how do we make it consistently available for any operator, whatever configuration they have in their asset. And we've done everything from flare capture projects where we're taking in gas that would have just been flared or shut in wells, where VoltaGrid to go to a well site, put their equipment on it, we'll clean the wellhead gas up, we'll push it to some compression, and we'll compress it there on the well site, or we'll run it straight into power generation equipment. Right? So there's a lot of different opportunities that you can take advantage of from an asset perspective. What do you think about how you use your fuel and your gas?
And in the oil field electrification world, where does the battery storage come in? So that would be like a step in between, just before your distribution trailer.
Yeah.
If you had that, because you'd be running in, charging up the batteries. What's their charge? everything's just going through the power distribution. And if for some reason everything cuts out, you got a few minutes of battery backup, basically, right?
There's a couple of different applications you can batteries for. And when I think about battery usage, it's not so much to power frac equipment by any means, because your power draw is going to be so fast coming out of that you're not going to get any sort of time, just because the sheer volume of power you need to run the equipment. Now, what you don't see is kind of all the ancillary equipment that sometimes we do power on location. So if you wanted to put the battery system out to help take some of that the energy and store it, and then we're going to run, whatever other auxiliary equipment, maybe it's some of the VFD components on our side so we can troubleshoot things to that component. But for actual fracturing downhole like power, we don't see batteries as
that's not a wonderful thing.
Yeah, no, not from our perspective.
And
those today.
Right. And this whole thing is kind of like a loop, right? Because like, let's say if you were using gas, right? Or if you were in this, once you frack and get everything set up, you're generating more gas that you can feed back in, like if it's all in the same field, right?
The beauty about the whole setup, we can use hydrocarbon from one wellhead to help you, produce hydrocarbon from another wellhead, right? So it's all hydrocarbon to hydrocarbon, right? It's a full feedback loop.
That's amazing. That's amazing. Well, this is a great example. We'll have to talk with the VoltaGrid folks. They were on our special series on oilfield electrification technology. We'll have to get them back and talk about this, because I know they've done a lot in the last couple of years.
Oh, man, sure. The last 2 years, it's amazing what they've been able to do between microgrids, flare capture projects, and keeping up with us as we've scaled our Zeus portfolio.
All right. Thanks,
man.
Thanks for tuning into this special series of World Oil Deep Dive, your go-to source for the latest technology in the energy industry. We hope you enjoyed today's episode and gained valuable insights to help drive your business forward. Be sure to subscribe so you never miss an episode, and follow us on our social media channels for more updates and industry news. Feel free to reach out if you have any questions or topics you'd like us to cover. Until next time, keep innovating and stay ahead in the energy sector with the World Oil Deep Dive Podcast.